double tube filters. Okay, so the double tube filter, this is the structure. Okay, that is result capacitance and inductance along with the resistance R1. Okay, so this is what this is the filtering circuit which we are going to add up to the original circuit. Okay, and now here I am going to calculate this R1. I am calculating this R1. So by that, what is our impedance of the filter impedance? That is Z that we know from the control system, that is we are taking the Laplace transform. That is Z f of s, that is equal to effective what is the Laplace transform, that is L1s, and for capacitance it is, for the first capacitance C1 it is 1 by C1s plus what is the overall here into the C2 and L2 are in parallel. So we will be taking it as 1 by, that is 1 by R plus 1 by, if it is 2 resistive parallel, we will take this 1 by R plus 1 by R. If you are cross multiplying this R1 R2 divided by R1. Based on that concept, it is for the Laplace transform of inductance, that is L2s into 1 by C2s divided by the sum of it, L2s plus 1 by C2s. Okay, since both the C2 and the L2 are in the parallel connected. Okay, and from this, this is a basic expression. From this, we are going to write what is the filter impedance for the overall of the filter system. So, if we are calculating the filter impedance, we can able to calculate how much amount of the things we filter. Okay, so by that, so here the L1s plus 1 by C1s will be the same, and in this step, what we have done is we have just taken out the L1s divided by total. If we solve this, we will be taking the cross multiplying, right? That is L2 C2, what will become S square will become S square plus 1. And now in denominator, what will be there? C2S. If we take C2S over here, what will come? It will be in the numerator. So here already there is a C2S, and both the C2S and C2S will get C. If you cross multiply it, it is L2 C2 S square plus 1. Okay, the denominator this term will be here. If we take it to the numerator, here is the C2S term. These two C2S and the C2S will get cancelled. Okay, and what is the term will remain? L2S divided by C2 L2 S into S square and this plus 1. Okay. Now, we are going to use L2s plus, and we are now going to cross multiply these two terms. First term is 1 by C1s, the second term is plus L2s divided by this denominator. If we cross multiply it, what happens here is 1 into this denominator, right? So it will be C2 or this interchange, that is L2 C2 S square is 1 into, right? So S square plus 1. And plus this numerator L2 S square, these two will be getting cross multiplied, right? That is L2 S into S will become S square along with the C1, and in the numerator what it will be, the both the things will be multiplied, that is C1 S into C2 L2 S square plus 1. Okay. These two terms are getting cross multiplied, and after that L1s into, now what we are going to do is we are going to cross multiply these two. So with this L1s into this entire denominator. What is this entire denominator? Before that C1s will be multiplied to the fourth term. That is C1s into S into S square will become S cube. Okay, what is the remaining things? C1 C2 L2, and again 1 into C1s will become C1s. Okay, and now this denominator is being multiplied with the first term L1s. Okay, and now here the remaining term, what it is? Remaining term is L2. What is the remaining term? L2 C2 S square plus 1 along with plus L2 S square C1. And in the denominator, when we have multiplied C1s plus C1, that term will remains. Okay, and further, what we are going to do, we are going to multiply this L1 S plus the entire system. Now, what will become? It will become C1 C2, that is the L1 here. So, L1 L2, and the S into S cube will become S power 4. Center that is a plus. become S square into what is here? L1, here is a that C1. If you notice here is also S square, here is also S square. Can we take it common outside? So what we have done, I have taken the common S square outside. So the remaining term is here there is L1 C1 S plus here what will be L2 C2 plus here L2 C1 or C1 L2. You can write it as terms. Okay. So in denominator it remains the same. Just numerator, I have multiplied this L1 and inside I am taking the S1 and common. Now what I am going to do is I am going to divide with C1, C2, L1, L2. Okay. In order to take a constant, that is 1 by C1, C2, all the inductance and capacitance values are constant. That we are going to fix in the filter. So I am going to make it the whole thing as a constant. I am going to consider it as either A or B. So for that purpose, what we have done is just divide C1, C2, L1, L2 in both numerator as well as in the denominator. Okay, so in this if in the numerator I divide it with C1, C2, L1, L2 means what will happen here? This term will become the C1, C2, L1, L2 will become cancelled, right? So what will remain there? S power 4 only remains there. And then the second time S square is common outside. Okay, and the term inside is C1, L1 plus L2, C2 plus C1. You can write it as C2, L2 also. Okay, not a big change with this. So next plus C1, L2 is remaining. What I am doing? The numerator and denominator dividing by C1, C2, L1, L2. And the next term plus there is no plus what's the term here? Plus 1. Okay, so we are dividing by C1, C2, L1, L2. So it is plus 1 divided by C1, C2, L1. And in the same way, the denominator also I am going to do. So the denominator, what is the term? I have taken the just S and taken common outside. Here is a term S2 and here is S, right? If you take this S alone common outside means what will remain inside? Remains it will be C1, C2, L2 S square plus C1, right? So like for that purpose I am taking S common outside. It remains C1, C2, L1 S square plus C1. And in the denominator, when the addition we are applying, we divided with C1, C2, L1, L2 or L2, L1. Okay, and now this is the term. Further, what we are going to do is S power 4, S square remains the same. Here, what it's going, all these things, so the numerator remains the same. Only the denominator is going to change. Okay, what we have done is here. We have just divided common taking. If we take here common outside means C. The C1, C2, L2. If we are taking common outside means what will remain from here is an C1, C2, L2, right? Here is also C1, C2, L2. Okay, so if we take common outside, what is remaining in the numerator alone? L1 alone. So S by L1. Okay, again, which term will remain here? S square plus what will remain here? 1 divided by C2 L2. The other terms are coming, it will get cancelled. Okay, only the denominator changes. That has S by L1 into S square plus 1 by C2 L2. Okay, again, what we are going to do is I have told you that C1, C2, L1, L2 all are constant. So in all the things we are going to use the single constant as A and B. Okay, what we are going to do is we are just going to assume this entire term. This entire term we are going to assume together as A. Okay, and the other thing, this term is related to us, we are going to assume it as B. Okay, since note down here all the values are C1 L1 based on C1 and L1. Since it is constant, we are taking it as overall constant A. And here it is 1 divided by C1 C2 L1 L2, which is also constant, and that we have taken it as B. Okay, so replace it with A and B. So what will happen? After replacing it, first replace it then S power 4 plus S square into A plus B divided by S square will remain. Numerator will remain. After that, what we can do? We can take it to cross multiply this, or else we can take this L power L1 is in denominator. We can take it as into the numerator. So what we have achieved? L1 is power 4 plus S square into the term is A plus B divided by the denominator remains the same. Just this L1 and we have just cross multiplied it. Or else, just if we cross multiply, what happens? It is L1 into S power 4. That gives us remains 16. Okay. Now we are saying that A is the term of constants C1 and C2, and B is other constants C with respect to 1 divided by C1 C2 L1. Okay. And now we are going to substitute in the impedance formula. That is impedance, that is filter impedance in the initial stage I will have right? This is the of course something over here. L1S plus 1 by C1S. By that we are going to achieve that because overall expression what we have achieved impedance of filter is equal to L1 S power 4 plus A S square plus B divided by what we have achieved S into S square plus 1 by we have taken this as ohm square. Okay, what is this ohm value? 1 by root of C2 L2, which is constant. Okay, and this filter is for the purpose it has to filter two frequencies. One is omega m1 and the other one is omega 2. You know the value for omega, it is 1 by 2 pi x. Okay, so based on that, it has to filter this frequencies. One objective. Another objective is if we add two single tone filter in parallel means the double tone filter can be designed. Okay, so based on that, what is the impedance formula? That is based on two single tone filter if you are connected in parallel means you will be achieving a double tone filter. The impedance formula is that is with LA just replacing this one constant with A and the second tone filter is as B. Okay, the first tone filter is A S plus 1 by C1. We can also use this is the case of first single tone filter and this is the case of second single tone filter. So two single tone filter is in parallel. Likewise, what will be the expression? If it is in parallel means the multiplication of 2 divided by the sum of the two. Right? Here just multiply them two. That is L1A plus 1 by CAS. Likewise, LBS plus 1 by CBS. And the sum of the two expressions. That is L1A plus LBS plus 1 by CAS plus 1 by CBS. That is two filters are in the parallel condition. So the expressions will be the impedance filter and impedance will be in this expression. Double tube filter, two single tube filter are in parallel. Okay, so we know the expression for now. What is the filter impedance? So from that, this is a diagram for it. There is two single tube filter that is connected in parallel. There is single tube filter of the capacitor, the inductor, and the resistor. And similarly for the second single tube filter, these two are connected in parallel for designing a double tube filter. So we know the expression for the Laplace transform. Based on that, I am going to derive an expression. How the responsibility. So first here it is LA for the first filter. Okay. So I will write the Laplace transform for it. LA S square plus what is the constant for the CA plus 1. Okay. So likewise divided by what? CAS. And for the second filter that is LB CB square plus 1 divided by CBS. Okay. And the denominator what is the sum of the both capacitors. So sum of it that is LA CSB SQ plus LB CA CB SQ plus this entire time. Okay. So after that what we are going to do is we are just going to cross multiply this. Okay. That is if it is a both extended multiplications, right? So what will become CA CB S square, right? What is the denominator? CA CB S square. For the denominator will get what? Will get cancelled. What is the term remains? LA square. LA square CA plus 1 with the multiplications of CB LB square plus 1. In the denominator, this terms will remain the same. Only the CA plus CB square. Okay, CA CB square and this CA CB square will get cancelled. Okay, and this denominator will remain. Okay, and the next one is what we are going to do is the denominator. What we are going to do here is just we are going to multiply these terms. This LA square CA is multiplied with LB CB square. So what will happen? S square will become S power 4 and the terms will be LA LB CA CB. Can you able to LA CA S square. Likewise, this 1 to be multiplied with the first term as well as the second. So what is going to be the first term? LB CB square plus 1 into the second term 1. It will become 1. Okay, and the numerator, what we are going to do is we have to in both the terms, if you notice there is a S cube term common. Okay, so in both the terms, what I am going to do, I am going to take the S cube being multiplied. This the four terms are getting multiplied, and what will remain is LA, LB, CCB, S power 4 plus so the next second term, third term, whatever will become the fourth term, and the numerator what we have had, I have taken the S cube terms. In both these cases, I have taken the S cube term common outside. So S cube term into LA, CA, CB plus the second term, that is LB, CA, CB. And if you look at the third and the fourth term, that is S is common. So I am taking S as common outside. What will remain inside CB plus CA. That is CA plus CB. Okay. And the next one, here in this term, what I am going to do is I am going to take LA, LB, CA, CB as common outside. So if you take the first term, LA, LB, CA common outside, what will remain inside? Only S power 4. And then the second term it is plus what it is in both terms, what is common? S square, right? So S square I am taking common outside. In the numerator what it remains? CLA, CA plus LB, CB remains. And in the overall term I have taken LB, CB, CA, CB common outside, right? In the first term it is there, so only the S power 4 remains. And in the second term it is not LA, CLB, CA, CB. So what we have to do? We have divided. Okay. So if you notice that if you multiply this LA, CA, CB in this term, both LA, CA, CB will get cancelled. This term remains, right? You will be able to get my point. So now the next term is here it is 1. What we have done? The entire we have taken LA, LB, CA, CB common outside. So here also I have to divide by 8. Okay. So what we have plus 1 divided by LA, LB, CA, CB. Okay. And the denominator what we have done is, if you notice that there is an S term common. Here it is S cube, right? So in both the cases there is S. So I am going to take the S as common also. So first time will become like this S cube will become S square. But the remaining term is, if you notice that there is also a CACB and here is also a CACB. If we take a CACB as common outside, means what will remain is the first term? Just LB. In center there is a plus. And what will remain here is LB. Since I have taken this CACB as common. CACB as common. Okay, and plus what remains here is yes, I have taken overall common outside. So what will remain inside? CA plus CB. Okay, and now this is your impedance. We have just write the impedance, right? So ZF of all the time there is a ZF of x. Okay, so that ZF of x is equal to LA, LB, CA, CB into S power 4 plus we can write this as say 1 divided by LA, LB, this denominator. I have taken this term first. Okay, and this S square into this term, right? This S square into LCA as second. That's it. I have just interchanged the second and the third term. That's it. And in the denominator, it remains, the first option remains the same. That's S into LA, LB into CA, CB. And if you notice this term, here it is a S square term, right? So S square plus what we are going to do is here it is a CA plus CB. Clear? And now here we are going to divide it by what is the term remains here? When we take overall term, what is the term remains? That is LA plus LB into CA CB. Okay. And now general equation. In the general filter impedance, we are just going to compare with it, which we have derived. Okay. In general filter impedance, this equation we compare is what is the value of L1 is, that is LA, LB divided by LA plus LB. Okay. Likewise, what is the value for C2 is CA, CB divided by CA, CB. Okay. So we have the first question I have drawn a diagram on it. First L1, C1, C2 and L2. And there is a double tube filter design. And what we have done here, we have just parallelly connected two single filters. So we are just going to compare these two things. What is that is the inductance L1. So we must know we have to compare that L1 with this LA and LB. Right? Since it is parallel, and if we join it together, means what will be doing? LA divided by LA plus LA. That is what we have to do. LA divided by LA plus LA. Okay? And likewise, what is the expression for C2? There is a capacitance that is connected in parallel. Did you remember this? Both are connected in parallel. First what happened? This is our, there is a inductance first initially, there is a capacitance C1 is there, then L1 is there, and what we have done? We have connected a parallel capacitance and parallel inductance. We have given the C2 and L2. These are connected over here. And from here there is a resistor that is also being plotted. This is a single double tube. This is a double tube filter. In this filter only, we have decided as two single tube filter is in parallel. So these two are in parallel state. So what we have done, C2 is equal to, in place of C2, what it is the CA CP. CA divided by CA plus CP. Likewise, in place of L2, what it is LA LB. So LA divided by LA plus LB. And in place of C1 and L1, how it is? Both are connected in series. So what is the result of C1 then? Addition of both. That is R plus R. That's it in series. So CA plus CP. And what is for L1? It is sorry L1 it is what it will be LA plus LB. That's what we have done. That is L1 is equal to LA divided by LA plus B. What is for L2? Sorry, that is for L2. That is LA plus LB. Okay. So these are the expressions. Okay, so from that to compute, I have told before that filter is designed for what? Filtering the two frequencies. One is omega 1 or omega 2. So that for we have taken this lambda from S, right? What is that S means? It is J omega H product of harmonics. Okay, J omega and H. Okay, so now this is f of S because this is the overall expression. We have comparing this is the of S, right? We have compared two expressions. This derived Z f of s with one equation compare and the Z f of s the you compare that is L1, L2, C1, C2 value we have right now. Okay, so what is the value of omega r? Okay, that is reference omega. What is this? 1 by omega L1 C1. Okay, and what is the value for x1? Omega r into L1 in terms of inductance and in terms of capacitance it is 1 divided by omega C1. And what is the value for omega with respect to the harmonic interference? Okay, that is equal to our reference omega and our frequency. Okay, and what is the harmonic? If we take here, from the harmonic that is equal to omega r divided by omega real frequency. Okay, that is similarly, what is the value for harmonics? Total harmonics there. That is H1 is equal to ohm 1 divided by that resistance. If we consider initial condition, we have included the R. If we consider it means what is the value? Omega r ohm 1 divided by this angular frequency 1 omega r. Likewise, what will be for the harmonics to H2? It will be like ohm 2 divided by omega 2. Okay. Since there are two frequencies has to be filtered. And then what is the expression for x2 then? That is ohm 1 L1 then in terms of inductance and in terms of capacitance it will be 1 divided by, you know that is x is equal to, in terms of inductance what it is? R L. Okay. In terms of capacitance what is 1 by R